Lab 24, example 1. We want to list all possible rational zeros, and then we want to find all rational zeros that actually exist, and factor f of x into a product of linear factors. So we have f of x is equal to x cubed minus x squared minus 34x minus 56. So the first thing we're going to do is list all possible rational zeros. So we're going to be looking at p and q. P is going to be the last number here. It's going to be the number that doesn't have an x after it. So it's going to be negative 56. For Q, it's going to be the leading coefficient, which is the number in front of the x that is the biggest. So here we have x to the third, that's the biggest x. The number in front of it is just 1, so Q is 1. And we're going to be looking at all the factors of P and Q. So factors of P. This is going to be a plus minus kind of situation because we can have negative factors in there too. We could have positive 1 and negative 56 or negative 1 and positive 56. So I'm just going to write it as positive minus everything. So for negative 56 we could have 1 and 56. Either one of those could be positive or negative. And then we can also have 2 and 28. 2 times 28 is also 56. And then we also have 4 and 14. And we also have 7 and 8. These are the possible factors of P. So then we're going to look at the factors of Q. This is also a plus minus kind of situation. Q is 1, 1 times 1 is 1, and also negative 1 times negative 1 is 1. So this is just, the factors of Q is just positive and minus 1. And now we're going to look at P over Q. So this is going to be a positive, negative list. Everything in here could be positive or negative. And we're just essentially going to be looking at combinations of all the factors of P divided by the factors of Q. There's only one factor, well there's two factors, positive and negative 1, but since we have positive and negative here, we can simply write it a little bit easier. So we have 1 over 1, which is 1. We have 56 divided by 1, which is 56. We have 2 divided by 1, which is 2. We have 28 divided by 1, which is 28. So really it's just going to be all of the factors of P. And because if we divide it by the factors of Q, it's just going to be itself. So this is 4, 14, 7, and 8. Positive and negative. So these are all the very possible rational zeros of our function here. We don't know which ones are actually the zeros, but these are all the possible rational zeros. So to find all the rational zeros that actually are real zeros, what we have to do is we're going to graph it. So take out your calculators, we're going to press on. And we're going to go into y equals, and in that y1 slot you're going to type in this function here. I've already done so. You're going to press graph to graph the function, and we actually see the graph here. It goes up and then down and it goes through again. And you can actually get your little cursor here and go to where it crosses the x-axis, and we find that we have it doesn't quite go there, but if you wanted to go completely correctly and find the actual zero, you could go second trace and then to 0 to actually make sure that's where the x-axis is. But since we have all the possible rational zeros, we can essentially just make do. We have here in our trace, we have x is about negative 4, so we know that our actual zeros from this list that are actually in this function is negative 4. That's our 0 there. If we scroll over here, we see that it's around negative 2. So from all these factors, we have also negative 2. And going all the way over here, we have x is about positive 7, which is again in our list. So we have positive 7. So these are all the possible rational zeros. These are the zeros from this list that actually are zeros. Well, the rational ones. The next thing we want to do is we want to factor f of x into a product of linear factors. So this should be very easy to do. We already have the fact that a is equal to 1. So because of that, it's just going to be a line of all of our zeros. So f of x is going to be equal to all of our zeros in factored form. So if we have x is equal to -4, then we have the factor of x plus 4. And if we have the 0 of x equals -2, then we have the factor of x plus 2. The reason we switched the signs is because we would set each of these equal to 0. We'd have x plus 4 is equal to 0, and that would give us x equals -4. We're just going backwards here. And for positive 7, we have x is -7. Again, if we set this equal to 0, then we would get x is equal to positive 7. And if we check through here, we'll notice that this is the same as this because we have our a, our leading coefficient here is just 1. If you multiply the first thing here, we'll have 1. We know that we have the correct amount of zeros because we have 3 zeros here, and we have x to the 3 here. So this is our f of x in factored form.